This is an Accuphase P300, and it was sent to me for repairs because it has an issue in the power supply, and the owner thinks that one of the Coke can sized main filter caps is bad. The P300 was released in 1973 under the Accuphase and Kensonic brand name. It's rated at 150 watts per channel and has a plethora of known issues I will be digging into, starting with the main filter caps. But first, a cool clicky door that covers the lower controls. There's a service bulletin out for replacing the main caps, as the ones installed in early models were not rated for high enough voltage from the factory. Later models like the one I'm working on tended to have other issues with the main caps, such as leaking electrolyte, and are still recommended for replacement. And you can see where it's gotten onto the chassis. The big blues look pretty good in there. Time to power test this. Voltages look good. Next up is the power supply. Thankfully, it's slotted in and comes out real easy. I'm gonna need to order these two capacitors. For that is I don't keep a lot of axial capacitors in stock where the leads are on the sides instead of on the bottom, which is more common. The other thing I missed is, I don't know how I missed it, these two resistors are burned to a crisp right next to where this heat shrink is shrunk back. They're cooked. I also noticed that there's some fuzz blown out in here, which is a capacitor fart. And the only two capacitors that looked like they could have farted out anything, this one that has black and this one that has black, test actually surprisingly fine. This one tests the worst. This one tests nearly perfect. These radial caps that I'm gonna put in have a little bit of the lead exposed, so I put some heat shrink tubing over the sides. Here it is with all new parts. I replaced all these capacitors, 8 diodes, and the 2 burned resistors. Out of these caps, these ones all tested fine. This one tested okay, and then these 4 all tested bad. They test open circuit or low capacitance, except for this one, which tests at 80 microfarads when it's rated for 1000. To go into a little bit more detail for the long form viewers, the power supply, you can see I have axial caps here and radials, and since there's these handy dandy slots for zip ties on the board, I went with Nichicon UPW and then Panasonic FR series capacitors, which are better than any axial cap that you can buy for a power supply. They have really low ESR and very high ripple current handling. They're also cheaper than the axials, and so I went with those in the positions that I could. And then I got these nice blue Vichy axial caps for the 2 that did not have zip tie slots. It's crazy that this was even functioning with these bad caps in here. I also cleaned up the back of the board a little bit, removed a lot of the flex mask. And we'll do a quick power test on dim bulb. Relay click. You can see how long it takes for those main filter caps to fill up. Right, so I've got the power supply reinstalled and I'm checking all the voltages on the bottom, and I noticed that there was some missing voltage, AC voltage, going out of the power supply. These 2 fuses were blown. I replaced the fuses, booted it up on dim bulb. They didn't blow. Plugged it into the wall outlet and I watched them go. I put this power supply back in after just testing every single resistor, every transistor, everything looks fine on here. And so I started testing other components because those 2 fuses are actually the B plus minus rails for the amplifiers. And so that would tell you that there's either a blown output transistor or something like that. But when I originally received this, it worked fine. I tested it and both channels worked. So I wanted to go back and check if I messed something up or if it still puts out sound, which it still does. So interestingly, I pulled all of these output transistors and the 2 drivers and they all test fine. So I also pulled the left channel outputs and none of these test bad. So all of the outputs are great. And then I pulled the left channel driver card, and this has definitely been worked on by someone. You can see these transistors should look like this from the factory. And the client is adamant that this has never been worked on before, but I can't see how these were the recommended replacement transistors for what was there for a long time, and they're just no longer available. So somebody has definitely been in here working on this. So I've just put 2 new 2 amp fuses in here where they've been blowing, and they don't blow when it's plugged into dim bulb. I want to test it there anyways, but now that I have all the outputs and driver cards out, I want to see if any of those are causing these fuses to blow. So they did kind of bend. I found these 2 diodes to be shorted, and they actually run across the backside of the 2 axial caps that I installed, and they're to prevent reverse current. Why that makes sense is because you can see this diode goes right here where I have the green text. It was added in later models, and mine had it, but the diode was just shorted. And you can see the voltages are really high, so 77 volts and 63 volts. And you can see the fuse down here is what's blowing, and that voltage is going in here as AC, it's going through this diode, and then it's meeting up on the other side of that crossover. And so pretty much there was a ton of reverse current across this capacitor through that shorted diode, which was causing this voltage to be high. This is what I'm guessing, and this is why I went to check these two diodes. This is completely my fault. I replaced these capacitors, took the diodes off and put them back on, and never tested them, and I totally should have. Okay, after a few more sets of blown fuses, I figured out that what the actual problem was that I had installed these diodes backwards. And the reason I'd installed them backwards is because whoever had installed them as per the service bulletin installed them backwards. I reinstalled them just following what was already on here because I assumed it was a short down the line. But it turned out these diodes were actually backwards, and that was causing, basically these diodes were then shorting out because they can't handle, they're very low current diodes. And so they would short out and then just allow a ton of voltage across this capacitor where it shouldn't be, which is why the amplifier still worked, because they were getting voltage. Next up are the driver cards. Soldering on the P300 boards is a bit of a pain. First, you have to remove the solder and old component, just like any other board. The leads on the new transistors are wider, so I then carefully enlarge the holes using a hand drill bit and remove any extra solder from the pads using my solder gun and isopropyl alcohol to clean them up. The copper pads tend to corrode on these boards, which makes soldering to them quite difficult. So I polished them with a fiberglass pencil before installing the new transistor, applying solder flux to each pad, and finally soldering each one. Finish it off by cleaning the new flux off of the joint. Finish the work on the driver card. 7 film capacitors, 1 electrolytic, 6 transistors, and 2 potentiometers. With both driver cards reinstalled, I set the DC offset to as close to 0 as I could and the bias to around 55 millivolts, then ran it at a 1 watt output for 45 minutes to warm it up before making final adjustments. Look at how clean that square wave is. Beautiful. And to make sure it stays beautiful, I cleaned and lubricated all of the controls. I also cleaned the contacts on the giant protection relay. I figure while I'm in here, I also want to put in some new LED lamps, because if the lamps burn out in this, then the amp stops working. I get asked a lot how I clean faceplates. My go-to method is to start out with a damp magic eraser or a damp microfiber. I've just found that the magic eraser is really good at getting off stubborn pieces of debris or paint, etc., while also still protecting the silk screening on the faceplate. Then I polish the faceplate using Mother's Meg and aluminum polish. I had someone recommend this to me at some point, and I just bought a big tub of it, and it keeps working, so I keep using it. Next up is the protection circuit. I started by replacing all of the capacitors, then tested the board and went back in to replace the op-amp that controls the low impedance detection circuit. The new op-amp requires a new circuit, so I also changed out a few parts for different values. And this is supposed to just make this circuit more reliable because this old op-amp is known to fail. I replaced 13 parts in total. New protection card installed. There's a few things I need to do to actually set that protection circuit. I attached a 1 ohm resistor to the main speakers and a 1.5 ohm to remote 1. Turned the trimmer on the protection circuit to full clockwise. Then we'll go ahead and turn the amp on, and these lights will start flashing. I'm on the 1.5 ohm resistor on remote 1 speakers. I'm gonna go down here and turn this trimmer until those lights stop flashing, counterclockwise. There we go. Protection relay clicks in. Then I'll go ahead and turn the amp off, switch this to main 1. And these lights should stay flashing because we now have a 1 ohm resistor on the main 1 speakers. And this means that the low impedance protection circuit is functioning correctly. That it's all done, we can see all the parts are replaced. This is 65 parts in total, and then 4 lamps, so 69, nice. All right, last thing to do before we listen to it in the living room is to test the output power. So watch those meters as we go up, up, and away to 150 watts or so. And we were just starting to get clipping there. And that comes out to 200 watts per channel. Definitely outperforming the 150 watt per channel spec. I've got it paired with a Marantz 2270 as the preamp, and man, it sounds good.